Hello everyone, I am Gaurav and welcome to my channel Code with GD. By the end of this video, you will be able to solve the famous problem, remove duplicates from a sorted array. This question has two variations and I will discuss the solution of both the variations. I will also tell you the brute force way to solve this problem and the optimized way, and at the end I will code for the optimized solution. So let's dive right in. The problem states that I am given an array and I have a certain conditions. The array will be in increasing order, like it will be a sorted array, and I know that the array has repeated elements. Remove duplicate elements from the array, but you should allow each element to appear at most twice. For example, if we take this input, my output should look something like this: 0 0 1 1 2 2 3 3 4, and then there can be other elements, I don't care about them. Now in this, since 0 appeared twice, I can have 0 twice, 1 also I can have twice, but in the input array I had 2 4 times, but my output should have at most 2 repetitions. So I have 2 2's and 2 3's. Now 4 was present only once in the input array, so my output should also contain 1 4. We need to return the length of this and modify the input array. So what will be the solution for this? Well, we can use the same brute force solution, where in the ordered map we could store the element and the number of repetitions for it. That is the brute force approach, and the time and space complexity will be exactly same like we had for the previous solution. Talking about the optimized solution, we will solve this problem with the two pointer approach. It's slightly trickier, so take your time to pause it and think of what I am saying. Assume we have again two pointers, I and j. Let's assume like j will be my pointer that will traverse the entire array, and I will be my pointer to mark the end of the unique repetitive elements. Initially we start both of them from the second place, the second position of the array. So initially both I and j will point to the second index. Now my condition is I will have a for loop, and which will keep on incrementing j till the end of the array, and inside this I will have a condition that says if the element if the current element, what j is pointing at, is not equal to the value which is 2 times before I, like since I is pointing to the end of the allowed repetitive elements, so since we are allowing 2 repeats, so we are starting I from the second position. Now if this is not equal to the value at I minus 2, in that case we will perform two operations. At the ith position we will put the value that will be present in j, and we will increment I. Now when both of them are pointing to 1, I see that the value at I minus 2 was 0. That means this block of code will be executed, and we store 1 at this position since j is also pointing to this location, and we increment I. So in the next iteration I will be pointing to this location and j will increment as per this. Now again same thing will happen, I minus 2 is 0, so both of them will again reach this at the next iteration. Now here the value of j is 2 and at I minus 2 we had 1. So again this block of code will get executed and both will move again, and we have got I and j. Now again at this point I gets incremented by 1 and the current value of j will be stored in I. So in the next iteration I points to this and j as it is gets incremented. Now things will get interesting. Now we see that this condition doesn't satisfy because value at j is equal to value at element I. So this block of code does not get executed and only j will increment. Now we again see value at j is 2 and value at I minus 2 is also 2. So again nothing happens and only j gets incremented. Now when j gets incremented, we see that value at j is 3 and value at I is 2. Now both are different, so this block of code will get executed. So we store 3 at this location and we increment I by 1. So I is now pointing to this location. And after the next iteration, j will increment by 1. So my j is now here. Now we see that again value at j is not equal to value at I minus 2. So again we store 3 in this location and increment I by 1. After all this, j gets incremented by 1. So j will go here. At this point, we see that value at j is 3 and value at I minus 2 is also 3, which is this, since we had updated the value. So nothing happens and j gets incremented by 1. Now j is 4 and value at I is 3, which are different. So our logic will get executed and we will add 4 here and we will increment I. Now for our return, we will directly return I, because if you see, I is the index I is the length of this array, which is my result. So my final result will be this, and we don't care of the other elements since we know this length, which will be the value of I at that time. Now this is the entire logic. If it looks complicated, take some time to see what is happening or reiterate this video and see what is happening. Talking about time complexity, I am iterating the array only once, so my time complexity is order of n. And talking about space complexity, we are not using any extra space, so my space complexity is order of 1. Now let's code for this video and see. Now this is categorized as a LeetCode medium problem.
A few moments later.
Now this is my code. First I find the length of my input array. I check it. If its size is more than 2, then I proceed. Otherwise I directly return the size of my array. This is to prevent any index out of bound exception. Since both my indexes start from the second index, I want to make sure the second index actually exists. So I initialize my I with 2 and j also with 2. Then I iterate j over the entire array, and then I have this condition which we saw. If element at index j is not equal to element at index I minus 2, I perform some operations. I assign the value at j to the value at I, and then I increment I. And I do this process till j reaches the end of the array and I return I, and that is the solution for this problem. To do a quick recap, we looked at the remove duplicates from a sorted array problem. We saw both the variations of the question and we saw both the brute force and optimized solution for this problem. The code for this problem is attached in the description below, so do check it out. And if you enjoyed this video, like it and share it with your friends, and don't forget to subscribe to my channel Code with GD. Till then, happy coding. Bye bye.